Rocket propulsion velocity at the exhaust relative to the rocket is equal to 2 km per second. If the mass of the rocket system is 1000 kg, then the state of fuel consumption for a rocket to rise up with an acceleration of 4.9 meter per second square will be equal to. Now they have basically asked that what is the rate of the exhaust for this rocket. Let us say the mass of the rocket over here is equal to m. Okay, now this rocket is moving up. Okay, so now when the exhaust gases are pushed in the downward direction, the same force will be applied in the upward direction. Okay, mg which acts in the downward direction, the resultant force is in the upward direction. Let the resultant force be equal to ma. Okay, so basically I can write this down as, I can write down the equation as the total upward force minus total downward force will be equal to m into a. Now what is the upward force? Now the upward force is due to the exhaust gases. Now when the exhaust gases apply the force in the downward direction, the same force is applied by the Newton's third law of motion, the same force is applied in the upward direction. So this can be written as dmv divided by dt minus mg is equal to ma, which is equal to v dm by dt is equal to m a plus g. Now understand that dm by dt is the rate at which the gases are exhausted from the, or the gases are removed from the exhaust. Now the velocity over here is given as 2 km per second. So in meter per second it can be written as 2 into 10 to 3 dm by dt, which I have to find out. Now the mass over here is equal to 1000 kg, which is equal to 10 to 3. The acceleration in the upward direction is equal to, the acceleration in the upward direction is given as 4.9. So I will take this as 4.9 plus 9.8. Okay, plus 9.8. So it will be equal to 10 to 3 and 10 to 3 will get cancelled out. 4.9 plus 9.8 will be equal to 14.7. Okay, 2 times dm by dt is equal to 14.7. So dm by dt over here, or the rate at which the exhausts are removed, will be equal to 7.35. Okay, which is 7.35 kg per second, which is option number C.